Alright, we are asked to obtain the value of k such that k raised to the power of 6 is equal to 2 raised to the power of 6. So we had that k raised to the power of 6 is equal to 2 raised to the power of 6. Let us move 2 raised to the power of 6 to the left hand side. Our equation becomes k raised to the power of 6 minus 2 raised to the power of 6 equal to 0. So therefore, this equation can also be expressed as k raised to the power of 3 or raised to the power of 2 minus 2 raised to the power of 3 or raised to the power of 2 equal to 0. But we know that a squared minus b squared is equal to a minus b and a plus b. Our equation becomes k raised to the power of 3 plus 2 raised to the power of 3 multiplied by k raised to the power of 3 minus 2 raised to the power of 3 equal to 0. So for case 1, we can say that k raised to the power of 3 plus 2 raised to the power of 3 is equal to 0. And for case 2, we have that k raised to the power of 3 minus 2 raised to the power of 3 is equal to 0. Thus, we have that k raised to the power of 3 plus 2 raised to the power of 3 is equal to 0. But a raised to the power of 3 plus b raised to the power of 3 is equal to a plus b, a squared plus b squared minus ab. Therefore, our equation becomes k plus 2 multiplied by k squared plus 2 squared minus 2k equal to 0. Our equation can be simplified as k plus 2 multiplied by k squared minus 2k plus 4 equal to 0. But if we have a multiplied by b equal to 0, a is equal to 0 or b is equal to 0. Therefore, we have that k plus 2 is equal to 0. Therefore, k is equal to negative 2. Also, k squared minus 2k plus 4 is equal to 0. From our quadratic formula, we have that k is equal to minus b plus or minus root of b squared minus 4ac divided by 2a. And a is equal to 1, b is equal to negative 2, and c is equal to positive 4. So if we substitute, we have that k is equal to minus 2 plus or minus root of minus 2 all squared minus 4 times 1 times 4 divided by 2 times 1. So our equation becomes k equal to 2 plus or minus root of minus 2 squared is equal to 4, minus 4 times 1 times 4 is equal to minus 16. Root of 2 times 1 is equal to 2. And this is expressed as k equal to 2 plus or minus root of negative 12 divided by 2. This can further be expressed as 2 plus or minus root of negative 1 times 12 divided by 2. So k is equal to 2 plus or minus root of negative 1 times root of 12 all divided by 2. But root of negative 1 is equal to I. So our equation becomes k equal to 2 plus or minus I root of 12 divided by 2. K is equal to 2 plus or minus I root of 3 times 4 all divided by 2. So k is equal to 2 plus or minus 2i root of 3 all divided by 2. Now from the equation, we can factorize 2, which becomes 2 open bracket 1 plus or minus I root of 3 all divided by 2. So 2 can cancel out 2. So k is equal to 1 plus or minus root of 3. Therefore, k is equal to 1 plus I root of 3 and k is equal to 1 minus I root of 3. Also, we had case 2. Case 2 says that k raised to the power of 3 minus 2 raised to the power of 3 is equal to 0. So a raised to the power of 3 minus b raised to the power of 3 is equal to a minus b multiplied by a squared plus b squared plus ab. Therefore, we can represent our equation as this. So we have that k minus 2 multiplied by k squared plus 2 squared plus 2k, close the bracket, equal to 0. So we know that a multiplied by b equal to 0. It's either a is equal to 0 or b is equal to 0. Therefore, we obtain that k minus 2 is equal to 0 or k squared plus 2k plus 4 is equal to 0. Thus, k is equal to 2. Now, from our quadratic equation, we have that k equal to minus b plus or minus root of b squared minus 4ac divided by 2a. So we know that from the equation, a is equal to 1, b is equal to 2, and c is equal to 4. Therefore, our equation becomes k equal to minus 2 plus or minus root of 2 squared minus 4 times 1 times 4 divided by 2 times 1. So our equation becomes k equal to minus 2 plus or minus root of 4 minus 16 divided by 2. So we can obtain that this becomes minus 2 plus or minus root of 4 minus 16 is giving us negative 12 divided by 2. So therefore, we can obtain that this is equal to minus 2 plus or minus root of minus 1 times 12 divided by 2. But root of minus 1 is equal to I. So we obtain that k is equal to minus 2 plus or minus I root of 12 divided by 2. We can have that k is equal to minus 2 plus or minus I root of 3 times 4 divided by 2. Our equation becomes minus 2 plus or minus 2 multiplied by I to 3 divided by 2. If we factor add 2, the equation becomes 2 open bracket negative 1 plus or minus I plus 3 all divided by 2. So 2 cancel out 2. So therefore our k can be expressed as minus 1 plus I with 3 and k equal to minus 1 minus I with 3. Now let's check if our solution is correct. We have two real numbers that k is equal to 2 and k is equal to negative 2. So therefore we have that 2 raised to the power of 6 minus 2 raised to the power of 6 is equal to 0. 2 raised to the power of 6 is giving us 64 minus 64 equal to 0. Also here we have negative 2 raised to the power of 6 minus 2 raised to the power of 6 equal to 0. So therefore here we have 64 minus 64 equal to 0. Thank you, and see you in the next video.